Ever since we were children, we have known that a balanced diet of food is necessary to keep us healthy. Now, in our teens, we're probably wondering why a balanced diet is necessary for good health. To answer that question, we'll define the words nutrition and metabolism. We'll define metabolism first. This boy is taking a test that will tell the doctor something about the energy requirements of the boy's body. This is done by determining the boy's basal metabolism. Basal metabolism, which is being recorded on this graph, is a measurement of energy, specifically the amount of energy released when the body is at rest. Like all of us, this boy requires energy for the hundreds of chemical processes which take place within his body's billions of cells. Energy is needed to build and repair body cells. All the cell building and repairing processes and all the energy-producing processes that go on within the body are called metabolism. Basal metabolism is the minimum rate of metabolism necessary to support minimum activity. Usually, the basal metabolism is determined by supplying oxygen to the patient through a mouthpiece. The amount of oxygen used by the patient is then recorded. Since this oxygen is used by the body to release energy, the amount of oxygen consumed can be mathematically converted to the corresponding amount of energy released in the body. This energy is expressed in terms of a unit called the large calorie. To understand this unit, let's take this example. A man weighs 200 pounds. The amount of energy required to raise him 15 feet is about the amount of energy in 1 calorie. And the adult human body generally produces every day a minimum of energy to raise this man 1,700 times. This amount of 1,700 calories is a minimum required to maintain the adult body properly, even when at rest. This amount may be less for boys and still less for girls. Using the basal metabolism or minimum energy requirements as a starting point, physicians can compute the active metabolism. For example, the active metabolism of a non-athletic student might be as little as 2,800 calories per day. For mechanics and others who do moderate physical work, 3,400 calories may be required each day. Athletes and others doing strenuous physical work may require as many as 6,000 calories each day for their active metabolism. These calories are produced from the foods we eat, which brings us to our second word, nutrition. Nutrition is the study of the kinds and amounts of food that are necessary to maintain proper health. All natural foods, such as these, are composed of 5 classes of chemical compounds called nutrients: carbohydrates, fats, proteins, minerals, and vitamins. The first 3 are essential energy sources. They supply the energy needed for active metabolism. Proteins, minerals, and vitamins supply essential chemicals needed by the body. Proteins are included in both groups, since they are a source of both energy and essential chemicals. Let's start with the 3 energy-producing nutrients. In their natural state, in foods such as these, the nutrients are too chemically complex to be used by the body cells. In the stomach and in the small intestine, nutrients are broken down into simple molecules which can be absorbed and used by the body cells. One of the essential energy-producing nutrients is carbohydrates, the chemical name for all kinds of sugars and starches. Table sugar and honey are pure carbohydrates. Foods rich in carbohydrates include potatoes, crackers, and bread. In the body, complex carbohydrates are digested to molecules of simple sugars. This is a diagrammed molecule of the simple sugar glucose. The diagram shows that the molecule is made up of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. When the oxygen we breathe combines with a molecule of glucose, energy is released for use by the body. In fact, each pound of glucose or other pure carbohydrate yields about 1,800 calories of energy. Another essential energy-producing nutrient is fat. Fat occurs in such foods as butter, the fat of meat, and shortening. Fats are digested to molecules of simple fatty acids, indicated by this diagrammed molecule of linoleic acid. This molecule is made up of 18 carbon atoms, 32 hydrogen atoms, and only 2 oxygen atoms. Because it has so many carbon and hydrogen atoms, when this fat molecule combines with oxygen, it releases a great deal of energy, about 4,200 calories per pound. The third energy-producing nutrient, protein, is found in lean meats, egg whites, and milk. Protein is digested into molecules of simple amino acids, indicated by this diagrammed molecule of glycine. This molecule is made up of 2 carbon atoms, 5 hydrogen atoms, 2 oxygen atoms, and a single atom of nitrogen, a chemical element not present in carbohydrates or fats. The presence of nitrogen in protein molecules makes protein an essential body chemical as well as a source of body energy. When pure protein combines with oxygen, it yields about 1,800 calories per pound. Rather than just a few favorite foods, a balanced diet, therefore, should contain proper amounts of all 3 of the energy-producing nutrients: fats, carbohydrates, and proteins. The best way to guarantee this is to eat a wide variety of natural foods every day. When eating meals, another important health rule to follow is to match calorie intake every day with energy output, that is, with active metabolism. For example, if calorie intake is too high, some of the nutrients will not be oxidized, and the excess will be stored in the body, primarily as fat. The resulting overweight may lead to poor health. On the other hand, if calorie intake is too low to satisfy the energy needs of the body, stored fat and then even vital tissues will be oxidized. The resulting underweight may also lead to poor health. This is the rule for good health. Adjust food intake to maintain the body weight recommended for your age, height, and sex. So far, we've related nutrition and metabolism to body energy. But body metabolism involves more than producing energy. Proper metabolism in any of the body cells depends upon a wide variety of chemicals. Many of these chemicals are manufactured by the body from elements contained in molecules such as glucose, which result from the digestion of energy-producing nutrients. But certain chemicals essential to the body cannot be manufactured from these elements. These are essential chemicals which must be present in the diet. They include minerals, vitamins, and amino acids. These nutrients build new cells, repair old cells, and provide those chemicals necessary for cell function. Let's begin with the amino acids, which we saw make up protein molecules. About 20 different amino acids, each of which contains nitrogen, have been chemically isolated from proteins. 8 of these amino acids are absolutely essential to life. These essential amino acids are not easily stored in the body. So it's important that every day we eat natural foods high in proteins which contain these amino acids. Such foods include lean meats, milk, eggs, and certain vegetables. The amino acids in these foods provide the cells of our bodies with nitrogen-containing compounds essential to the chemical processes of growth and repair. Also aiding growth and repair is the second type of essential chemicals, minerals. Among these, the importance of iron and calcium can be most easily seen. Foods rich in iron are meats and eggs. After digestion, iron from these foods becomes one of the chief components of hemoglobin, which gives blood its color. Hemoglobin also plays a vital part in transporting oxygen from the lungs to the tissues of the body. Another system of the body, the skeletal system, uses the mineral calcium. Large amounts of calcium are needed during the early years of life for the formation of bones and teeth. Among the foods rich in calcium are milk, cheese, and most vegetables and fruits. Many of these same foods contain the third type of essential chemicals, vitamins. Demonstrations with laboratory animals will show why we need vitamins. These mice are healthy and alert. They will be fed, over a period of weeks, a diet containing adequate amounts of all vitamins. These mice are also healthy and alert, but no B vitamins will be included in their diet. After several weeks, the animals fed sufficient amounts of vitamins are still alert and in good health. However, the animals which have not received B vitamins are clearly sick indeed. Through thousands of similar experiments, scientists have determined that vitamins supply chemicals necessary for proper metabolism. In this film, we have seen how certain nutrients in food are necessary for metabolism. We have learned of some of the chemical substances which make up these nutrients. We also have seen how doctors determine how much energy from food our bodies need to function properly. And throughout the picture, we have related these points to nutrition and metabolism, and what these concepts mean to your good health.